Hey, welcome everybody. Thank you to coming to our session today. We got a special one. Been at Microsoft for almost 30 years. One of the closest partner relationships we had over that entire time is with Intel. Did you know that our team regularly talks to, at a very deep level, the Intel team, not only about what innovations they're doing in their technology, what they were doing today, and how we can take advantage of that as a database product, but like ahead of time. Like we're talking to them ahead about what does their technology look like down the road, because it's important for us to know that. We want to know how can we make our database product more secure and faster, and they're one of the great partners to do that with. So we're really proud to have this session jointly with them today. I'm Bob Warden, architect on the Microsoft Azure Data Team. Maybe you saw me this morning in the keynote talking SQL 2022, showing some cool demos. So here's what I'd like to do. I'd like to spend some time in the beginning just giving you, make sure, setting the landscape for what is in SQL Server 2022. And then I'm going to hand it over to my colleague David Pless, who has spent deeply some time with Intel on specific functionality in 2022 that takes advantage of Intel technologies. And then we're very proud to have online with us Darren Frymouth. Darren has worked with us for a long period of time.
Wave, Darren.
Yeah, wave to the crowd here, Darren.
There we go.
So then we'll let Darren take over and talk about some of the new inventions in Intel technologies. And Darren has a deep knowledge, not of just Intel, but also of SQL, so a great partner of ours. So we're looking forward to this session today. Hey, some logistics. We have some of you folks online. Welcome online to you. If you will post your questions online as we're speaking, we'll have fixed points in the session where we'll turn and answer those questions. I've got some folks here in front of me here that will tell us what those questions look like. But for those in the room, we got like a boombox thing. Don't we have a boombox? We have a boombox thing that we'll hand to you. You can speak and tell us the question. We'll repeat the question.
Yep.
Those online who can hear it, and then we'll make sure we do that. So if you got some questions, kind of hold on to those. We'll stop in those fixed points and see what questions you have. And certainly, I think, Dave, at the end of the session, we have some resources as well.
Yes, absolutely.
So, yeah, I think we should kick it started, right?
All right, let's go.
All right. So when you think about SQL Server 2022 overall, the very first thing you should know, and we kind of painted a picture a little bit this morning in the session, is that we want you to take advantage of your SQL Server assets on premises, but connect them in Azure in new and exciting ways. You're going to hear more about that at this event for sure. And those of you on my workshop yesterday saw a lot of that in there. And we're going to connect to things like managed instance for disaster recovery. Hey, you saw a demo in the keynote of that, right? How we're going to connect to Synapse for near real-time analytics and connect to Purview. You saw the Power BI guys show Purview a little bit. What Microsoft SQL Server can do now is use Purview as a governance tool to set up access policies. We are huge on security, though. Anybody remembers the Slammer virus? That was a big moment in time way back long ago for us, and it changed the landscape and mindset for us on how we do security. But it's not just the fact that we're the least vulnerable database in the industry. We want to provide technologies like Ledger, a blockchain built inside the SQL Server database. And benchmarks are critical. Our partners that we deal with, folks like Dell and HPE, using Intel technologies, publish really high-performant benchmarks to make sure you know there are standards for OLTP applications and analytic applications. So we really believe those benchmarks are important so you can see the standard that SQL upholds. But we want to make sure you have technologies like built-in query intelligence to get you faster with no code changes. Now, tomorrow, I have a session called the Wheel of Power. Did you hear those little hints today in the keynote? Wheel of Power. Why do I call it the Wheel of Power? Dave, you could go to the next slide for me here. Think about SQL Server as a hub and the spokes as major categories. First being that cloud connected story I talked about, and that's cloud on your terms. You connect SQL Server on premises, any cloud you want to, then connect with Azure to get more functionality. We'll talk in a second about some of the capabilities of built-in query intelligence. That is some of those powerful features we've put into the product itself. What we want to do is if you're going to run technology like Intel, we better make sure we take care and use as much as possible that processing power. So we're going to build things into the query processor to make sure we do that. But the meat and potatoes is security, scalability, and availability. And you're going to find out in the rest of today's session, we're going to dive a little bit into some of those integration points with Intel technologies that are going to make you more capable in these areas. But we also want to make sure you can connect to things like data lakes. Did you know that you can take a SQL Server, like I showed in the keynote, and go access Parquet files in some lake somewhere as a table? That's new technology that's interesting and new to SQL Server 2022. And the core T-SQL language, we have not forgotten about you. We have poured our heart into actually adding new core T-SQL functions and enhancements of functions to make sure we keep that language alive and well. But let's talk about built-in query intelligence as a technology. Let me go ahead and I think I've got that oops, sorry, Dave.
It's all right, no problem.
I just messed you up, man.
Hey,
I should have let Dave run the keyboard. I just totally screwed him up. Let's go to wheel of power. Okay, built-in query intelligence. So Dave, you could kind of forward through this one a little bit, right? Let's just get one more here and right there. Here's the deal. In SQL 17 and 19, we took the query processor and said, look, we know common problems you run into. We want to make sure we keep this fresh and alive. So we've got a next generation of IQP technologies trying to solve things like parallelism. You saw a quick demo from Aaron on that this morning. Or even CE model feedback problems, and especially parameter sniffing problems. And here's what's interesting. We're going to combine that with the query store. We've enhanced the query store. We believe we've shored up problems that you may have faced with that technology in the past, and utilize that in a new and exciting way. So there is a series of IQP functionality that we can do, and if you kind of look through, let's see here, let me go, I think down maybe?
Arrow.
There we go, arrow here. If you look through the whole IQP feature set, you're going to find all sorts of interesting automation that we've done to get you faster with no code changes, including things like parameter sniffing, including solving things that we've done in the past, like taking advantage of batch mode on row store. If you look at IQP and this intelligent query processing as a set of functionality, that's in the core engine, no doubt. We think it's so important that it's part of the whole wheel power on its own accord. But here's the thing. I had a mentor of mine, David Campbell, who used to run the SQL Server product team for many years. And I joined engineering, and he was leaving Microsoft. And he pulled me aside and he said, look, if you don't invest in these 3 areas in the SQL Server engine, you don't have a product. You can connect it to the cloud, you can take machine learning, you can build all sorts of capabilities, but that core engine, the meat and potatoes of SQL Server, you better make sure you continue to innovate on that. And so I mentioned before in security space, can you imagine having a blockchain inside your database? And you're asking like, why would anybody want that? Well, it's a tamper evidence proof of data in your database, kind of like you would have a blockchain, but infused and built easily into the SQL language. Or how about the fact that you should take advantage from a scale perspective? Again, we talked about Intel technology. If you're going to make this investment with their latest processors, you got to make sure you scale. So we can't have the software holding you up. So we've made great innovations in the scale space, including things like buffer parallel scan, where we just make sure in large memory systems that we don't hold you up for operations like creating databases or backing up databases. And then, did you see my little demo about latching, free of latching? So we're going to show you in the Hidden Gem session on Saturday behind the curtain about what we do about that. But take a look at availability. Not only did Aaron show you the contained availability group space about now agent jobs are replicated, but how about the fact that you can do things like snapshot backups, backing up terabytes now in seconds, or you can be able to restore those things in seconds. And here's a great example that we're going to talk about in part of our session today. Why not go partner with companies like Intel to look at technology to offload high-intensive CPU operations to special parts of hardware that they provide, or now even built into the newest slate of their chips, so that you can free up your workloads to run faster? Why not take things like compression and just offload that so that your queries can actually run faster? So we believe over 25 plus features in the SQL Server engine in 2022 have been produced. And some of the deepness of what we've done here is to partner with folks like Intel in their area of scalability, in their availability, to make sure you can get faster. You want to continue to make sure the investments you've made with them, that SQL Server doesn't hold you up, but also even gets better. So what I'd like to do now is turn over to my colleague David Pless to kind of dive it. Dave, one of the things I got to call out for Dave, because I work with him closely about all sorts of stuff in the SQL Server product, is that he really spent a lot of time, deep heart and soul, working with Intel on some of this functionality. So there's no better person right now to turn it over to talk about that functionality, and then also let Darren take over and talk about some of the great innovation Intel has done. So Dave, take it over.
Thank you very much. I appreciate that. So the Intel QuickAssist Technology backup compression, this is an interesting topic, and it's where, wow, that is hard to read. That's actually hard to read. So Darren, feel free to jump in at any point. Do we have his audio? Are we good with audio for Darren? Okay, excellent.
Can you hear me?
Excellent. Jump in at any point here, because what I want to talk about is there's a couple aspects of this, the SQL Server perspective of built-in acceleration and the possibilities for future accelerators in SQL Server, okay? So Intel QuickAssist Technology is the first foundational accelerator that we have, but I want to talk a little bit about the challenge that we have currently with backup compression. How many of y'all are compressing your backups now? So how are y'all doing that? Just shout out, actually with the talking box, I like to call it the talking pillow. How are y'all doing that now? Just shout out and I'll repeat it. What are y'all using to compress your backups? So, anyone using any third-party scenarios, third-party solutions? Right, so random, so we're introducing some, compute overhead for that? What if you had a problem with it? Who would you call? I mean, hopefully that third party has some support that you're dealing with. Has anyone had any issues? Now I'm seeing some heads shaking, right? So that's the problem, is any third party scenario, it's not native, right? And it's all software based, and it's going to add compute overhead. When we consolidate and have very dense systems that are under pressure, right? So a lot of the customers that I have, like if you think of like a retail customer, everyone talks about Black Friday. I've had some customers that are florists. They care about 2 days out of the year. They care about Mother's Day and Valentine's Day. And if you're pushing up against those workloads, I mean, people don't have brand loyalty when they're buying flowers. So if you have an issue, if my backups are running when customer workloads are coming in and that compression is pushing the machine over the edge, you've got a huge issue, right? So you don't want to be in the position where I'm choosing customer workloads versus my business continuity and disaster recovery strategy. That is not a place for anyone that wants to be in, and certainly not a DBA. So why do we compress backups? Capacity is a big one, performance is another one, but we can't be in the position of pushing against customer workloads. So what's the answer? Hardware offloading and acceleration. Now, why did I position it like this? And this is where I'm in front of Darren. Darren's going to, again, feel free to chime in here. From a Intel QuickAssist Technology perspective, some of y'all may have heard me talk about this before, but I'm going to stress it's an important point. Hardware acceleration protects the host machine. It protects the host machine. The hardware device that you're going to may or may not be more performant than the host machine. I see a couple of people going like, wait a second, what? So let's say one of these older, Darren, the 8970 Intel card, how long has that been out in the market?
A few years, yeah, more than
a few years, 4 years. So if I have a really big machine that is not under pressure and I'm offloading to an external card, I could be slower, right? Here's the thing though, I'm protecting the host machine though. So that may be an okay thing for me. With the Intel QuickAssist technology, I have a choice. I can choose to offload from a hardware perspective to protect the host machine, or if I'm not under pressure and my system is running somewhat idle, I could choose to use software mode. Software is always a failback. So if my device were to fail, my backups don't fail. I still have software as a fallback. On SQL Server 2022 Enterprise Edition, SQL Server 2022 Standard Edition, it's software only. Okay? All right. Darren, anything to add there? Bob, anything?
Nope.
Okay. All right, so let's move forward. So what I want to talk about is first of all, how do we enable this? When I turn this on or off, I am turning on or off any accelerators on the system. Currently, the accelerator that we support is the Intel QuickAssist Technology accelerator, okay? Now, once I do this, then here's where the choice comes in. Am I going to use that hardware mode that I was talking about, or am I going to choose software? So I need to, in this case, I'm turning on the hardware offloading on. I'm choosing the accelerator as QAT, or I could choose software mode. Right? Now, in this case, I would need to restart because I'm loading those protected third-party drivers into the SQL Server process space on start with that choice being made. Okay? Now, from a troubleshooting perspective, and I absolutely love this DMV, I love the way that it was implemented, makes it easy for me to see exactly what's going on, what the driver is, what the software library is, and more importantly, what the state is. Did it load? Did it not? If it's software, why is it software? Is there a device problem? It's perfect for that situation. Absolutely love the way this was implemented to help customers and help support troubleshoot. Then I back up. Now here you see that I'm using the algorithm QAT deflate. That is how you would leverage this technology to say that I want to use the QuickAssist technology algorithm for my backup. Or I choose MS Express. Now, we do this across SQL Server product, the principle of do no harm. I don't want to break your backups. So you have all these other backup scripts already. We're not going to break it. The default is still going to be MS Express. Okay? Any questions right now? I know I'm moving kind of quick, but any questions so far? I don't see any online either. Okay. So that's how your operations from a backup perspective would go. Okay. Now, this is important. If you are leveraging the QAT technology, from a DR perspective, I'm going to bring this up again. I recommend having it on all of your DR machines because you cannot read a QAT compressed backup unless you have the Intel QAT drivers. I also recommend having those up to date. So if you were to do even a restore header only from disk for this backup, in order to see what I'm showing you here, which shows what the compression algorithm is, I need to have those drivers in order to do this, okay? It's actually a kind of a best practice. Now, from a restore perspective, because the QAT is part of that backup, I don't have to specify the QAT compression algorithm here. Your restore database scenario works just the same as it has before. And again, this is the DMV that you want to leverage when you're kind of getting any insights into what's going on here from a troubleshooting perspective. In addition, absolutely leverage error log. So in the error log here, if I'm looking for what's going on here from a troubleshooting perspective, you want to see that it sees what the compression library is, sees that I have Intel QuickAssist technology available, what the storage library is, what mode it's in, and see if there's any other issues going on. If you see any issues, we can it'll point you to the troubleshooting guide, and in the Intel QuickAssist landing page, gives you more details along with white papers and the latest drivers. Darren, anything you want to add here, or we're all good?
We're good.
Perfect. Okay. In your history, so definitely want to recommend continuing to look at the MSDB backup set and any kind of other history that you're pulling from your backup behavior, and you can see that we're tracking the compression algorithm, so we make it very clear, so you can look over time how optimal your backups are from a compression perspective and how long it's taking for those backups to complete for the compression algorithm you happen to be leveraging. So that's all native and part of SQL Server 2022. Okay, so some best practices. I mentioned one of them. Definitely get the latest cumulative updates. Always do that. Also, always get the latest drivers and make sure the drivers are consistent across the machines that you have in your environment, especially your disaster recovery machines. You don't want to have part of disaster recovery in that failover. You don't want having to deal with another driver, another thing when you're going over to one of your sites from a DR perspective. So make sure there's consistent across your environment, because you know one of your first steps as far as a recovery perspective is restoring your databases and getting them online. Okay, so let's take a look at a demo. And in this demo, I'm actually going to be stressing the machine, and we're going to actually see the hardware benefits compared to the default and with and without load on the system. In this case, I'm actually using one of those 8970 PCIe cards in this machine. So I'm going to turn on the accelerator, and I'm going to make the choice here specifically to choose hardware mode, and I'm specifying the QAT accelerator. Now, remember, when I do this, in order to load those third-party drivers into the SQL Server process space, I'm going to have to restart the SQL Server service. So you're going to see me do that here in a second. Okay. Very good. And like I said, I love this DMV. I love the way it's implemented because it makes it really obvious what's going on, and it tells you quite a bit about the health of the environment. So I've run that, and you can see the accelerator. You can see the description of that accelerator, what mode it's in, and why is it in that mode. I can see if it actually has detected hardware, and what specifically the accelerator library, the accelerated version is. And Darren may get mad at me a little bit because I'm definitely out of date when it comes to my drivers. So he's probably going to send me an email.
Yeah.
I'm a little out of date, Darren. I apologize. So we're looking at our error log, and you can see, just like I showed on the slide, I can mimic what I'm getting from that DMV. Though the DMV is going to give us richer information when it comes to like the reason code and why are we in that particular state. I'm going to do a quick baseline, and I'm doing MS Express backup with no compute overhead being applied. This is important. It's just a baseline, right? So I like to bake a cake. This is my way of baking a cake, y'all. Okay, so it completed, and I'm going to take that. It's what, just over 3,000 megabytes per second. It took about 85 seconds to complete. It's a pretty good baseline. So I'm going to take this informational message and drop it in. And I'm going to do another backup, but this time I'm going to stress the box. This is that scenario I was talking about a little bit earlier. What does it look like when a box is under pressure and you're having to make that choice between customer workloads and your backup strategy? So I'm using some sysinternals tools, and I'm hitting it pretty hard. I'm pushing right up 94% CPU utilization here. The point here is not so much how long the backups take. Again, this is protecting the host machine. So I'm doing this backup with 94% processor utilization, and I've pushed it up over the edge. So my backups are running, my customers are not. My customers are suffering, workloads are suffering, my application could be timing out, I could be having all kind of interesting compute pressure that is affecting customer workloads. So after that backup is completed, I'm going to grab this here and notice 87 seconds is very close to what we had before. Again, it's the customer workloads I'm worrying about here. 87 seconds, 2,916 megabytes per second. And that time it was with pressure. Now, remember, I'm still pressuring the box, but this time I'm going to use QAT deflate. We have 94% processor utilization. We're gonna see that here, okay? 94%. Remember, previously I pushed it over the edge. Let's see what happens this time now that I'm leveraging the QAT deflate algorithm with Intel QuickAssist Technology. Only 3%. So I'm under that 100%. I only went 3% above what I did before. So my customer workloads are successful because my backups are not pushing the box over the edge. But there's a key point that we're going to see at the end here that I definitely want y'all to notice. So we're going to take this informational message. We're going to put this in here, and I'm going to do a really quick comparison. Notice from before, it was 87, almost 88 seconds. This is MS Express. Took 2,916 seconds, or I'm sorry, 2,916 megabytes per second. The other one was 76 seconds, so it's about 10 seconds better, but guess what? The MS Express was 85 seconds, 3,000 megabytes per second throughput without overhead. the Intel QAT hardware scenario outperformed it with overhead. That is a big deal, and that's on an 8970 card. So if you think about what Sapphire Rapids is going to be able to do, that's going to be really interesting, and that's what Darren will be able to talk about a little bit later. Darren, anything to add here? This is pretty cool that the Intel QuickAssist technology can give us this kind of benefit protecting the host machine in this way.
Yeah, it's great. Yeah, like you mentioned, the numbers only get better when your QAT adapter is on die.
Yeah, absolutely. So another quick thing here, and I know that you wanted to talk about the AVX-512 technology specifically. What I'm going to show here, I'm going to talk a little bit about column store indexing, what we did in SQL Server 2022, and then I'll show how to enable it, right, and how you can track how AVX-512 is being leveraged. So we had this ordered cluster column store capability. We're sorting data in memory before the index builder compresses the data into index segments. This helps us with segment elimination. It's a really big deal, especially in really large systems, large data warehouse systems. But I think one of the biggest things here is also the segment elimination capabilities extended to string, binary GUID, and date time offset greater than 2. So from that perspective, that is a really powerful thing. So we're getting a whole lot more segment elimination than we got before. But we can take this a step further for read-only batch mode operations, and this is where AVX-512 really kicks in and helps us benefit in those workloads. So the trick is here, how do you enable it, and how do you track that it's being used? So I'm going to show you that really quick, and then I'm going to hand this over to Darren. Okay, this is pretty simple. So what I'm going to do is create an extended event, and we're just going to see just really how do you enable this. First of all, nothing's running. No trace flag is running at all at this point. And I'm just going to watch this extended event, watch this live session here. And I'm going to take this query. It's the same query that Ajay and I demoed before. And it's going to run pretty fast. But the trick here is looking at what the CPU instruction set, what is being used. And we see that AVX2 is being used, but what's available is AVX-512. In order to leverage this, we have to have a trace flag in order to do that. So I can enable it, and it does not require me to restart the SQL Server service. And then that is an important piece here. So 15097 is enabled. I'm going to run the same query again. And now I'm going to go back to that extended event. I can see that AVX-512 is now being used for that particular query. Now, I will say this. Just because AVX-512 is available, that does not mean you should just do it. And your hardware and mileage are definitely going to vary, right? So for the later Intel-based, Sapphire Rapids-based processors, we're going to see a lot better performance. And Darren is going to get into that a little bit more and why that is. Okay. All right, Darren. I will just say next, and I'll move forward a slide. How does that sound? Oh, and you know what? This is a good time to pause here just for a moment, Darren. I apologize for that. Any questions? Do we have any questions online or anything? Okay, so I have a couple here. Yes, get the talking box, or I got to find a good name for that.
So you mentioned that you need to enable this for the backups. You need to enable this QAT on the machines which supports it. So you take a backup and you want to restore to a different machine which doesn't support it.
You have to, at minimum, you have to have the drivers. You don't have to have the hardware, but I have to have the software in order to restore that.
So there's like a different tool. So for instance, I want to restore to a virtual machine, which is not Intel-based. So can I load the drivers and restore it, or is it?
You could be on a Azure SQL virtual machine. You could be on an M series, E series. It doesn't matter as long as you have those drivers. So it does not, again, it does not have to have the hardware. It does not even have to have a virtual device that mimics the hardware. You just need the drivers.
All right, okay.
if you run your SQL Server in a virtual machine, so Hyper-V, and the hardware has these features, is it available? Does it work?
I apologize. The
Yes.
last part of
The question is, does it pass through on a virtual machine? The answer is yes, right? So if you've got hardware in your virtual machine, if you're running like Azure Stack HCI, for instance, and you've got QAT adapter and a virtual machine, it can be used from the pass through the hypervisor.
Okay, very good. All right, so I'm going to move forward. Darren, can you tell us a little bit more about AVX-512?
Yeah, it's first. Sorry, can't be there. Would like to been there, but actually we started the animation.
I can go back here.
Yeah, I can go back. So earlier, earlier you talked about this AVX-512 features on SQL Server. So I'll talk a little bit more about how it accelerates workloads on SQL Server. So if you want to restart
Sure.
I'll try to keep up with it. Okay, so today's workloads often need to perform identical operations across multiple data elements. In the original scalar processing days, a single instruction could only be performed on a single data element at a time. This resulted in long delays to process large amounts of data. Recognizing this need, to move on to scalar data, Intel began integrating SIMD instructions into Intel processors in the late 1990s. When SSC technology was launched, it provided 128-bit registers and SIMD instructions, enabling up to 4 or 32-bit data elements to be processed simultaneously to accelerate performance. Intel AVX and AVX-2 then extended register width by 2 times, doubling the performance of supported operations. AVX-512 not only doubles the width of each register, but doubling the number of registers to minimize latency and loop overhead. AVX-512 also adds new instructions and other optimizations to accelerate specific tasks for modern workloads. Microsoft, as David pointed out, Microsoft SQL Server is able to use AVX-512 to be more efficient when using batch mode read-only column store indexes. So, I mean, that's kind of the quick trying to keep up with the video, but that's quickly what AVX-512 is all about.
Okay, so we've been using AVX to some degree for quite some time, and we're going to get quite a bit more out of the newer processor SKUs with AVX-512. Is that essentially what you're kind of getting at towards the end? Okay.
Yep. So it's all, yeah. So then next I wanted to chat a little bit about Sapphire Rapids, or the fourth generation Intel Xeon Scalable processors. You know, some of you may have heard in early January, Intel released a new processor. So building on the decades of data center network and intelligent edge innovation, the new 4th gen Intel Xeon processors are now delivering leading performance with the most accelerators built into a data center processor in the industry. So we talked about some of the accelerators. I'm going to talk about more. I go through some of the accelerators that are in there as well. Intel 4th gen Xeons are being used to tackle the most important computing challenges across AI, analytics, networking, security, storage, and HPC. So when comparing sort of with prior generations, 4th gen Intel Xeon customers can expect a 2.9 times average performance watt efficiency improvement for targeted workloads when using the built-in accelerators. Up to 70 watt power savings in CPU optimized power mode with minimal performance loss. And this should provide a 52 to 66% lower TCO. So in addition to the AVX-512 that I covered earlier, I wanted to cover more about the Intel 4th gen Xeon accelerators and extensions that are included. So one of the first ones is the Intel Advanced Matrix extensions, Intel AMX. It accelerates deep learning, inference, and training workloads such as natural language processing and recommendation systems, also image recognition. There's the Intel Data Streaming Accelerator, Intel DSA for short. It's designed to increase performance for data mover and transformation operations and providing high performance for storage, networking, and data intensive workloads. Then there's the Intel Memory Analytics Accelerator, Intel IAA, that improves analytics performance while offloading tasks from the CPU cores to accelerate database query throughput and decrease memory footprint. Another accelerator is the Intel Dynamic Load Balancer, Intel DLB. It provides efficient hardware-based load balancing scheduling of packets, dynamically distributing the data across multiple CPU cores. This enables efficient core-to-core communication. And then lastly, we've already talked about, I'll cover it more in depth, is Intel QAT. It's primarily a compression and encryption technology, and we went through this earlier, but I have some slides. I'll cover it more in detail. Go ahead and move on.
So next?
Yeah, next. Sorry.
Okay.
First, I wanted to talk about how Intel fourth gen Intel scalable processors and how they perform with Microsoft SQL Server. This slide shows the results of some of the benchmarking that we've done in Intel Solution Labs. This benchmarking was done with HammerDB to measure the performance of SQL Server 2022 between using a 3rd gen Intel Xeon and a 4th gen Intel Xeon. You can see that the result of this testing kind of shows that a 4th gen Intel Xeon provide up to 19% more NOPM transactions over a 3rd gen Intel Xeon with OLTP workloads. That's that first graph there. It's the number of transactions. With DSS workloads, this is this other graph on the right, we also shown that up to 19% faster query response time with 4th gen Intel Xeons over the 3rd gen Intel Xeon. So this is some of the goodness of moving to the 4th gen Intel Xeon scalable processor.
I see acronyms quite a bit, Darren, so I'm assuming SPR is Sapphire Rapids?
Yes, otherwise known as Sapphire Rapids. So in the industry, you might know it as Sapphire Rapids.
And what is ICX?
Also,
for the
ICX.
audience.
Oh, sorry. Yeah. SPR. I guess it's on there. ICX is Ice Lake.
Okay.
The previous, which is 3rd gen, and SPR is Sapphire Rapids, which is 4th gen.
Okay. Excellent. Thank you for that. So next.
Yep.
Okay. Top performing database.
One thing I'd like to call out, and I think Bob mentioned this at the top. Is I'd like to highlight some new performance sort of metrics that have been released recently. So many of you might be familiar with TPC.org. It's an industry benchmarking site created in the 80s with a mission for creating good benchmarks and a process for reviewing and monitoring benchmarks. So all benchmarks on TPC.org are independently audited prior to submission. So recently, in the last month or so, around the beginning of February, I guess it's a little more than a month ago, Microsoft SQL Server Enterprise Edition running on a Intel 4th gen scalable processor was awarded the top spot for TPCH performance for non-clustered database in the 10 terabyte size. So this slide shows the top 3 in the 10 terabyte category, and then the bottom part of the slide there shows the system that was benchmarked. You can see the system was a 2-socket 4th gen Intel Xeon 8498 with 60 cores per socket, and was able to achieve a score of over 2 million queries per hour in the 10 terabyte size. So I think that's kudos for the 4th gen processor and SQL Server 2022.
Okay.
Next.
All right. Intel QAT backup compression.
Yeah, so now I want to go back and talk about what a little more about QAT, and we saw the demo, and we saw, and David showed us how to use it. But I wanted to talk a little more about what you can expect when using QAT with SQL Server. So Intel QuickAssist Technology it's a technology that implements hardware acceleration and improves performance across applications and platforms. It includes hardware acceleration for symmetric and asymmetric encryption, authentication, digital signatures. But what SQL Server uses it for is lossless compression, lossless data compression. And and it significantly increases the performance and efficiency of platform solutions. As shown earlier, Microsoft SQL Server integrates with SQL Server QAT hardware compression technology, and it accelerates the backups on compute-intensive workloads. In performance, so this bottom part of the slide, in performance testing with QAT third-gen scalable processors, QAT using a QAT PCI adapter and in Microsoft SQL Server, SQL Server is shown to have up to a 2.3 times speed up with database backups. So that means your backups are up to 2 times faster. But also backups done with QAT have seen up to a 6% reduction in backup file sizes over the built-in compression of SQL Server 2022. So this means that over time you'll use less storage space to maintain your backups as well.
Numbers that you have on the slide here, this was very similar to the demo that I had. This is using the Intel QuickAssist technology, but I'm using these numbers are the 8970 cards, correct?
Yes, this is a comparison, third gen Intel Xeon with built-in software compression of SQL Server compared against a third gen Intel Xeon processor used with the QAT adapters.
Yep.
So this number does not include fourth gen Intel Xeon.
Yeah. So we're certainly going to be better than this for SPR. Okay.
Yeah. So it's a good lead into the next slide. So the next slide is this is the study with the fourth gen Intel Xeon scalable processor. With the fourth gen processor, there's a next gen version of Intel QuickAssist technology. It's now built into many of the processor options. And so since it's built in, the performance of QAT gets even better. So here again is a comparison between SQL Server backup run with a default software compression on a third gen Xeon, and it's compared against a SQL Server backup run on a fourth gen Intel Xeon using Intel QAT acceleration. So in this case, we're seeing up to a 3.2 times backup time improvement. So this is the same baseline as the previous slide. The baselines are the same. They're both third gen processors with using default software compression, and we can see that between the third gen processor with a QAT adapter being 2.3 times and the fourth gen processor with QAT built in, it's 3.2 times, up to 3.2 times improvement. So performance numbers get better.
Not only am I getting the benefit of protecting the system with hardware mode, I'm also shrinking down the window in which my backups are running, which makes it a lot even better for customer workloads that happen to be competing against that time space. Excellent. Yeah. Excellent. Next. So
I wanted to cover some best practices. I think you went through some best practices. There's probably some more we can talk about here. When you're using QAT, I mean, some of the things stay the same, right? So whenever you're doing backups, the storage devices with high-O standards, such as SSDs, are, always going to get your data backed up quicker and get done quicker. So I recommend using higher performance drives. And file count matters for backup performance. So it's always recommended to leverage multiple backup devices aligned to separate disks to get the best performance, so that you can stream the data to multiple backup devices. And then, yeah, as David mentioned, hardware compression protects the host CPU. So Intel QAT adapter mode is designed to protect the underlying host system. And Intel QAT hardware mode provides the best performance when underlying system is under high workloads. When the system is not under high workloads, Intel QAT software mode still provides good performance, but Intel QAT software mode will have a higher compute overhead compared to the built-in MS Express due to having a more intensive compression algorithm.
Yeah, so really kind of the message there too is to really seasonally know kind of and prepare for that scenario. So if I know that I have a window, let's say a Black Friday window, or the florist example that I gave is that, okay, so I know that I'm up against this, I'm gonna switch to hardware mode versus software mode. So if I can predict from a seasonality perspective that, you know, I can prepare for that situation.
Yeah, one last sort of BKM, which I think didn't make the slide here, which is QAT on chip has less latency to the bus and therefore performs better than its PCI counterpart. So I think we already sort of covered that, but I just wanted to call it out here that when the QAT adapter on chip is always going to be faster because it's just closer to the chip. It's less bus latency.
We have 3 minutes roughly, but what you just said is a good segue for the last slide, because here we're kind of, all of our tests and scenarios was leveraging that 8970 card.
Yep.
And I know that if we have multiple cards, you can use those together to get better performance. But a lot of, especially the customers that we were working with, Darren, don't want to give up that PCIe slot. So how is this next gen gonna not only help me avoid that, but gonna be better from a performance perspective?
Yeah, so we talked about how QAT performs. As I mentioned earlier, so QAT is built into many of the Intel 4th gen Intel Scalable processors. That would be the first choice. The first choice would be used, if you've got a new system, would be to find this option with the 4th gen, with the QAT built into the 4th gen processor. If you don't have, if you have an older system, some older chipsets had the QuickAssist adapter technology built into the chipset, so you might want to check your systems and see if they have that option. If you don't have it in the chipset in your older system, then your last option would be the QAT adapter. There's two QAT adapters, the 8960, 8970. The only difference is the 8960 has one QAT accelerator, while the 8970 has two. And we can cover that last slide in the last couple minutes. And so this last slide, I wanted to sort of talk about the 4th gen Intel Scalable processor options, and sort of point out how you can tell if the option that you're considering has QAT or not. This is a bit of an eye chart, so I'm not going to kind of go through it in depth, but I did want to point out that the highlighted columns there,
not every SKU has QAT, is I think you're outlining there.
Yeah. So the highlighted, that shows the column that says whether or not it has a QAT device. If the number is 0, then the processor does not have a QAT on the chip. So if you're interested in QAT, you should make sure that you choose an option where the number is not 0 and has one or more QAT adapters.
Yeah.
Or accelerators, should say. And that's
it. This is the last slide. Now, there was a question.
Well, you had some. Okay.
I did, but really quick. There was a question. When auto-seeding high availability to rebuild an availability group, does it leverage QAT? So I would think not. That we're not with an auto-seeding scenario in an availability group. I don't see it would not leverage the QuickAssist technology in that regard. Yep, and we are at time. Thank you very much, everyone. Appreciate you joining. Thank you, Darren. Thank you, Bob.
Thanks.
And I'll hang out for any last questions for y'all.